Today I want to spend a couple of minutes talking about the quotient property of exponents, but specifically talking about what we do when the quotient property is used when your base is a number instead of a variable. So to explain that, to make it clear, I want to back up just a little bit and talk about what the property says. So when we have x to the fifth over x to the third, what that really means is we're doing x times x times x times x times x. In other words, 5 x's, right, divided by x to the third, which is x times x times x. And then we can cancel these three with these three. In other words, one at a time, just like 2 over 2 is 1. So x over x is 1. And that leaves me with x squared. Now, certainly we don't want to do that every time, especially if these exponents are really large. We would rather have a rule. And what I know you see is that, hey, instead of writing these all out and just canceling when we have 1x on the top and 1x in the denominator, canceling each of those, why don't we just subtract exponents? So the rule says if you have x to the m divided by x to the n, then the answer is x to the m minus n, as long as m is bigger than n. If it were the other way around, if n was the larger number, then we would still subtract, but not in that order. We do bigger minus larger and leave the answer where the bigger number is. Okay? But now, what happens when you have constants? What a lot of students want to do is just cancel this 5 and this 5, right? And that would give me 1. But we know that's not correct if we use not the rule, but simply just use the property that says 5 to the third is 5 times 5 times 5. And in the denominator, that's just 5 to the first power, so that's 1 5. And this 5 cancels with this 5, which leaves 5 to the second power, right? We know that. If we use the property instead, or the rule, remember there's an implied 1 right here, so this answer would be 5 to the 3 minus 1 power, which would be 5 to the second power, which gives us the same answer as what we got before. But now what about that numerically? What's really happening? Now we know 5 to the third is 125. 5 times 5 is 25, times another 5 is 125, divided by 5 to the first is 5. Now if we divide 5 into 125, that gives us 25. Feel free to use your calculator. Now is that the same result? Well, sure it is. We know that 25 is 5 to the second power. So you could handle this numerically, or you could handle it with exponents, but you can't do both. So again, a lot of mistakes that I see students making is if you have, 7 to the let me make that bigger, 7 to the, 15th over 7 to the 12th, you cancel those 7s. But you can't do that when those are raised to a power, so be very, very careful about that. That's not possible. To do this problem instead, you would simply subtract those exponents. 15 minus 12 is 3, and that's 7 to the third. And then if you wanted to know the numerical value, you multiply 7 times 7 times 7. Another problem, let me squeeze down here in the bottom. Actually, let me make a new page so it's not so confusing. So what if I give you, 4 to the fifth times, since it's something you learned a couple of sections ago, times 4 to the third. Another similar mistake, as in canceling the 7 and the 7 or the 5 and the 5, people would multiply those together and get 16 to the 5 plus 3 is 8. Once again, that's not correct, because if you're dealing with exponents, just deal with the exponents. In other words, 4 to the fifth times 4 to the third would be still 4 to the 8th. Remember, the rule is you add those exponents together. If you needed to see that with a different problem where it might be more clear, if you had 3 to the second times 3 to the first, right? Now we know that is 3. Keep the 3. Don't tell me that's 9. It's hard not to do. That's 9. It's not. It's 3 to the third. But if you think about that logically, that's 3 squared is 3 times 3, and that's 3 to the first, which is going to give you 3 times 3 is 9 times 3 is 27, which is exactly what this is. So if you're dealing with exponents, you keep that same base. You can't multiply those together or divide them to simplify that. And then the last problem, I want to take a look at 6 to the 17th divided by 6 to the 24 power. All right, so the rule is you subtract bigger exponent minus smaller exponent. So 24 is bigger. That means my result goes in the denominator. So I have 6 to the 24 minus 17 that goes in the denominator. Well, what in the world goes in the numerator? Well, it's going to be a 1 up there, okay? And then that's going to give you 1 over 6, and then 24 minus 17 we know is 7. So the answer is 1 over 6 to the 7th. Now if you wanted to know how to do that numerically where the 6's cancel, you would have to write out what 6 to the 17th is, which is enormous, and divided by 6 to the 24, which is even bigger, and then find the greatest common factor that goes into both of them. But I'm going to tell you the truth, that greatest common factor is going to be that 6 to the 17th, which is an enormous number that would be a common factor. So it's so much easier to work with the properties of exponents rather than trying to cancel the bases. I hope that helps. It's a very confusing topic to folks. Have a great day.